Hello, everyone, and welcome back to the FUNWAVE application on the ERDIG HPC portal. In this tutorial, we will focus on the third tab of our simulation workflow, the Input and Output tab. More specifically, we'll focus on this first section, the Temporal Specifications field. And in here, you will find the variables that define the resource allocation for your simulation, as well as its runtime and output plot interval. Now, this is the third video in our FUNWAVE portal video tutorial series. Please check out the introductory videos describing this platform, as well as the bathymetry and topography tab of this portal, this tab too. So to get started in this input-output tab, first and foremost, we have the number of cores in X and Y available here. Now these, if we hover over the info icon, we see that the number of cores in X is our PX variable, and the number of cores in Y is our PY variable. And these values are directly related to the size of your numerical domain. So if you recall in the previous video tutorial on the bathymetry tab, we had specified the size of our domain with mglobe and nglobe variables, roughly on the order of 1,000 points in the X direction and 500 points in the Y direction. Moving back to the input-output tab, the number of cores in X and Y, or the PX and PY variables, they essentially define how that numerical domain will be handled in the parallel processing environment on the high-performance computing machines, or the HPC machines. Now, back in the day, we used to have parallel computations with one core or one CPU with a single processor. Now, processors have cores, and they're multi-threaded. Now, the terminology between processors and cores is a little fuzzy, but we can consider the number of cores as the number of processors, but really think of a core as the most fundamental logical unit that you have in a processor. So in this example, 36 cores in X and 36 cores in Y may be a little bit ambitious for our simulation domain size. Recall that is 1,000 points in X and roughly 500 points in Y. So instead, let's say that we choose 10 cores in the X direction and 5 cores in the Y direction. What this means is that you're requesting a total of 50 processing units or 50 cores for your entire simulation on the HPC, where the X direction of your domain is split up amongst these 10 processing units to be solved in parallel, and the Y direction is split up amongst these 5 processing units. So when you do go to request how many nodes or cores you need for a computation in the following tab, in the Run tab of this workflow, you would have to have at least 50 cores available to you on the HPC machine, just to give you an idea. Now, if you were to enter a negative value or a non-integer in either of these fields, you would receive an error message saying that that's not appropriate, and it offers an explanation of the error. And this is true for most every field. Throughout this workflow, if a value is outside of the bounds, outside of the logical bounds for that specific value or variable, you will receive an error with an explanation. So for example, if we were to specify a floating point value here, we would have this red text appear with an explanation saying, you know, we need a whole number here that must be greater than 0 for this value to work. And if you notice, our little red icon button is grayed out. We're not allowed to save this info since this is not an appropriate value for this parameter or for this variable. The same error would come up if we put in a negative value, since it is also not greater than 0. So we can put 10 in here, and our red save icon button reappears, and we can save our work. Be sure to remember to save your information, to save your data in the current tab by clicking that button before moving between tabs. And as a reminder, this example is for a two-dimensional simulation. So we have access to both cores in X and Y. If your simulation is one-dimensional, you will only have the cores in X field to specify the number of processors or cores to use for your simulation. Now, the last two fields in this particular section are the total time of your simulation and the plot interval. The total time will be the number of seconds in physical time that you want your wave simulation to run. So for example, if you want to run waves for 750 seconds of physical time, then that's what you would enter here. The plot interval is the interval of how often you would want to write or output the global variable data that you've requested. And when we review the outputs section of this tab in a subsequent video, you'll know what I'm referring to with respect to global variables. These are things like surface elevation and velocity, for example. Now, these global variables will have dimensions, the size of your actual grid, so the size of that M globe and N globe variables. And the plot interval defines how often you want to plot that output to write that file. If you wanted to have an output every 100 seconds of your simulation, let's say, you would put that here. So in this case, you would get 8 outputs from this simulation, including the initial output at 0 seconds, and the last output would be at 700 seconds, since these are, it'll go up to the highest integer. Lastly, let's quickly go through where these 50 processors or 50 cores are defined for your simulation in the Run tab, just to connect. We'll save before we move tabs, go over to the Run tab, and scroll down to the bottom. So at the bottom of this page, you'll find some variables needed to submit and run a job on the HPC machine. Just to keep in mind, you will need at least 50 cores to run your simulation based off of the inputs we provided in the Input tab. So for this simulation on our Onyx HPC machine, one node is equal to 44 cores, or one node has 44 cores available. In this case, we would need to allocate at least 2 nodes. We would need to allocate or request at least 2 nodes, which would total 88 cores available to cover our 50 cores that we've requested to run our simulations. Now, if you submit the job with only 1 node or 44 cores allocated, your simulation would fail because you wouldn't have enough resources to run your simulation. We'll cover more details about allocating and submitting your job in our following tutorial on the Run tab. Overall, this concludes the tutorial on the temporal specifications field of our Input/Output tab in our modeling workflow. Always remember to save your changes with that Save button at the bottom corner of your screen, bottom corner of your workspace before moving across tabs. And if you have any questions, be sure to check out the Wiki either by accessing these little icons or going directly to the Wiki page. And if you do have any other issues, feel free to contact us via email as well. Happy modeling!